Jay Bartow is the CTO of Madrona Venture Labs. As many of you know, Madrona Venture Labs is the incubator inside of Madrona Venture Group. And Jay will be talking in our next tech talk. Jay is a serial entrepreneur, technologist, and machine learning and computer vision enthusiast whose startup career spans more than 20 years and includes co-founding a number of venture-backed data analytics companies, which were acquired by companies such as Microsoft, Nielsen, NetRatings, and Hulu. Jay is going to be talking today about democratizing access to machine learning and pre-trained models and cloud services. So welcome, Jay.
Thank you. Thanks, Todd. We'll get our PowerPoint going here. And I'd like to introduce my colleague, Yujiro, who's also at Madrona Venture Labs, who will help me advance the slides, given I have my hands full. Okay, so first one. So who am I? As Todd was saying, I'm CTO of Madrona Venture Labs. I'm a serial technology entrepreneur. I'm a machine learning enthusiast, and started learning about machine learning in 2001. About 20 years ago, I joined a small startup called NetBot, which was a University of Washington technology transfer company, where I met two computer science professors who got me interested in machine learning. Since then, you can see a number of companies I've co-founded that are in different verticals using different types of machine learning. So what we work on. So we look for technology startup ideas that are aligned with Madrona Venture Group's investing thesis. And that's fairly easy to do because they have a pretty wide investing thesis. Our critical work is, after we come up with ideas, we carefully vet them for market, product, and technology fit. Having been a serial entrepreneur for many years, I know from experience that entrepreneurs like to build first and ask questions later. And I found throughout my own experience that if you ask some questions up front, you can often save yourself a lot of time and heartache. So we ask a lot of questions up front. And as a result, we end up killing most of the ideas we work on because for whatever reason, they just really don't pass muster. Oftentimes because we can't make an argument that they're venture scale ideas, that they're big billion-dollar companies. But ultimately, we try to get a couple of companies out the door each year. Mostly what I focus on is machine learning companies, so-called vertical AI companies that use machine learning in a particular vertical. Think vertical like travel or insurance or construction, someplace where there's a problem to be solved by machine learning, and ultimately machine learning is a core component to the solution. But for these types of companies, we need data scientists and machine learning experts to solve these specific business problems. So let's talk about data science and machine learning landscape here a little bit. One really important thing to point out, which a lot of my talk is based upon, is the fact that in the last 3 to 5 years or so, we've seen a ton of really exciting growth and change, especially with deep learning. And so particularly exciting has been the emergence of robust solutions due to big data, of course, compute power, and the reemergence of neural network learning algorithms. So a lot of the functionality I'm going to talk about is based upon these concepts. So when I first started getting into machine learning, there wasn't much out there to leverage. There were some basic tools like Weka, a Java-based machine learning toolkit. There was a handful of arcane textbooks, ones that I read over and over again, studying the formulas, desperately trying to understand them. And now, fast forward about 100 years, and what's it like to do data science today? For those that want to pursue a traditional data science education, there's now a ton of online courses. There's a myriad of books, blogs, websites aimed at software engineers and data analysts and business professionals. And an incredible array of open source data science and machine learning toolkits. I really wish I had these resources when I started out with machine learning in the early 2000s. And so if you're really motivated, the world is your oyster. But a formal data science education is overwhelming to many. even when there's strong interest in learning. Even basic mathematical foundations like linear algebra and statistics and calculus are daunting to many who are interested in machine learning. So, as I said, there's a big learning curve here. You can see that the required skill sets for a data scientist are pretty unicornish. There's obviously, as I mentioned, a big learning curve. And it's also somewhat of a black art, given that there's often many ways to solve a particular problem and a large search space of possibilities to explore. It's very time-consuming and expensive. To get a full appreciation, let's look at some of the processes involved in model creation for a data scientist. So let's see. The life of a data scientist. So many cool models to play with, except for the fact that data scientists usually spend most of their time prepping and cleaning data, 80% of their time by some accounts. Making data useful from the real world, which is usually messy and difficult to work with, is a lot of what the work of a data scientist does. Historically, engineering features that are predictive of the problem being solved is where a lot of the time and energy is spent. And of course, labeling data for supervised machine learning applications is very expensive and error-prone and can take a long time to do. And that's phase one is really a lot of what data scientists spend their time on. And now the fun part. So once I have a labeled data set, I can divide it up into a training and a test set, which helps me understand how accurate and robust my model is. This phase is typically iterative. We keep exploring the space of solutions until we find something that meets our needs. Again, very time-consuming and can be fraught with pitfalls, like under and overfitting, which essentially means my model is not going to perform very well out in the wild. What comes out of this process is ultimately a trained model. And if it's solid and robust, I can now use this model out in the wild to predict or classify things I've never seen before, sometimes referred to as inferencing. Like a code library, I can also share it with someone else. Remember this idea. More on this later. Here, the input feature vector could be anything. It could be an image, it could be a credit application, it could be a blob of text, and of course the output is some kind of prediction that's related to my business problem. And note that inferencing can be done in a lot of different places. It can be done in the cloud, it can be done on a local machine, it can be done on a mobile device, it could also be done on a dedicated piece of hardware that has custom inferencing capabilities. So that's a high-level overview of a typical data science and data modeling process. So what's happening with data science in the cloud? Many of the cloud vendors offer support for this large selection of really awesome open source machine learning platforms. MXNet, TensorFlow, Keras, etc. But there's also several cloud-native machine learning frameworks that emerged from several vendors, like Amazon and Google, Microsoft, and IBM. Many of these platforms strive to insulate the data scientists from ops work. So setting up environments, installing dependencies, activities that most data scientists are happy to hand off. Some platforms include capabilities to ease the pain of data preparation, that kind of first nasty phase I was talking about, and feature engineering and handling large-scale data. Ultimately, though, you still need some data science and machine learning background to use them effectively. You need to really be a trained data scientist. And so, data science and machine learning engineers have quite a few tools to choose from, and they're getting slicker and easier to use. So between more accessible educational materials and increasingly user-friendly cloud machine learning platforms, you'd think we'd be in pretty good shape training up the next generation of data scientists to work on a myriad of these emerging AI ML problems that are driving so much of tech today. But you'd be wrong. No, that's good. Turns out there's a big shortage of data scientists. By some demands, there's not a lot of these, by some measures, there's not a lot of these folks. And we all know, I think, that they're rare and expensive. So we need to be able to democratize this technology. And this is what I find really exciting, is putting this kind of technology in the hands of software engineers and business people to be able to leverage this to build applications. And ideally, we can do it cheaply, because the cheaper it is to experiment with this stuff, the more people are going to experiment and the quicker it's going to be able to be adopted. So again, when we think about democratizing machine learning, we have education, we have increasingly smarter platforms, but we can also leverage models trained by someone else. I'll call these pre-trained models, or PTMs. I'll use that term PTM quite a bit throughout the rest of the talk. Leveraging other people's or companies' models reminds me of software reusability. Although pre-trained models are just files, they lend themselves to being hosted in the cloud. And I'll talk a little bit more about that in a bit. They're coming in many different flavors these days. So let's talk about a bunch of these flavors and see what's the landscape of offerings out there. So lots of going on here with pre-trained models with different cloud vendors. It's really a who's who of machine learning at this point. And I want to reiterate the benefits of PTMs from cloud vendors. As I mentioned before, large vendors like Amazon, Microsoft, Google, IBM, all have a ton of data and a ton of computational power to build powerful models, host them, and charge for them. Here are some of the top pre-trained model vendors. There's a million of them, but I'm only mentioning a few here just because there's only so many I can fit on the slide here. These are definitely the big ones. You know, again, the big guys, Microsoft, Google, Amazon, IBM, offer increasingly comprehensive and competitive functionality. I'll come back to this in a little bit, but a lot of these guys are offering really similar models to choose from. And I think this is great because it'll drive innovation up and prices down ultimately over time, which again, I think is key. Startups like Algorithmia, Seattle's own Algorithmia, in fact, offer a huge array of pre-trained models. And so if you're interested in starting to play around with these models and stringing them together and seeing what you can do, highly recommend you start with Algorithmia. So let's look at some categories. Computer vision is one of the biggest categories. You know, once the laggard discipline of machine learning, computer vision is now at the forefront thanks to convolutional neural networks, aka CNNs, which are a particular type of deep neural network, or DNN. One interesting thing about CNNs in particular is that they inherently discover the best features for the predictive part of the model. No feature engineering required. This is really cool because, you know, as I pointed out before, data scientists usually spend a lot of time engineering features for their models. And again, it's somewhat of a black art. CNNs have taken computer vision applications to the next level in a lot of areas. So let's look at what some of the subcategories are for computer vision. So here's Google's general image labeler. This is the most common type of image analysis. Pretty much everybody offers this functionality as a baseline. By the way, this is my dad and his cousin in front of Ellis Island in New York City. And you can see Google does a pretty good job at labeling the images with tags and associated probabilities, or something resembling a probability. It's important to remember that just a few short years ago, the pre-CNN state-of-the-art was much less effective than it is today. Here's the landmarks view, and I think I'm impressed with this. You know, it recognized that that's Ellis Island, which I thought was super cool, and then I realized, well, maybe it's just leveraging the geodata that might be in the EXIF metadata in the image. But I hope that it recognized that building, because it would be really cool if it did. So you may be asking, okay, well, a generic image labeler is great, but I need something more specific. And so we're starting to see more specific models be published by a variety of different vendors that basically, you know, deal with different classes of images. So Clarify is a really interesting computer vision startup that's offering an increased number of models trained for different categories. So, you know, here we see like travel, weddings, food, apparel, logos. They have a couple of different, a dozen models, and every time I check back, they have more. So I think that's pretty cool. And of course, faces. There's many different face detectors available out there in the cloud with varying levels of accuracy and quality. I've long been fascinated by face detection. It was one of the first working models I trained up myself back in the day. Here, Amazon Rekognition with a K deserves a shout out. The first time I played with it, I was blown away by its accuracy and detail of information. Not only does it detect faces, but it reports on a number of interesting attributes about the face. So, for example, it gives you all the points on the mouth and the nose and the eyes, but it also gives a whole bunch of interesting metadata on age range, gender, pose, whether the mouth and eyes are open, whether the individual is smiling, their emotions, sunglasses, eyeglasses, mustache and beard. Pretty amazing, pretty cool technology, and pretty cheap too. So if you have facial analysis you want to do, you just plug this right in and you're ready to go. Deep style transfer. So like a lot of things produced and enabled by CNNs, I was blown away the first time I saw style transfer. Style transfer is basically a powerful way of editing images enabled through CNNs via an optimization or learning process. You effectively transfer the style from one image onto another. There's several ways to achieve this effect using a pre-trained CNN. Really amazing, and I believe many of the popular image editing programs now on mobile devices use some form of this technique. And of course, there's several cloud vendors that offer PTMs, that can do this for you. YOLO. I had to show you this. This is just so cool. This came out of, YOLO came out of UW and AI2, led by Ali Farhadi of XNOR fame. YOLO stands for You Only Look Once and is known as a single-shot deep learning object detector. It's able to find bounding boxes of objects in a single-pass CNN. This is footage from my dash cam, which I ran through the YOLO system. I had a whole movie here, but then I realized trying to show a movie embedded in a PowerPoint was asking for disaster, so I just took one picture. This is open source technology. It's incredible to me. Just a few years ago, something like this was just almost unimaginable. Note that YOLO consists of training and inference capabilities as well as a pre-trained model. So my confession here is that I did run my dashcam movies through YOLO in the cloud on beefy GPUs, but I could have also run it on a local machine. So not entirely cloud native, although I imagine it's just a matter of time before someone offers functionality like this and I can just upload my video and it'll just do its thing. Someone may already. Okay, moving on to text analysis. Lots of text functionality out there in the cloud. Like images, many pre-trained models, are solving common text analysis tasks. Some of these models have been around for a while as part of open source text analytics toolkits, but the cloud versions typically use state-of-the-art DNN methodologies, are trained on large amounts of data, and offer performant inference. So some highlights here: named entity recognition is a common text analysis technique that's been around a long time. It finds things in sentences like people, places, and organizations. Sentiment analysis has become a staple of a lot of text analysis toolkits or people's bag of tricks. We use sentiment analysis quite a bit on projects at Madrona Labs. Getting a read on the positivity or negativity of a piece of text has all kinds of interesting applications, a couple of which I'll point out in a bit. And then, of course, two very big ones, speech-to-text and language translation, have been worked on for a long time. And recent advances in deep neural networks and recurrent neural networks have significantly advanced the state-of-the-art with these things. And so, although they're not perfect now, they're pretty powerful and, again, off the shelf and ready to use by almost anybody. So here's Microsoft Azure's Cognitive Services tester app. And the sentence here, if you can't read it, is, unfortunately, it rained during my entire trip to Seattle. I didn't even get to visit the Space Needle. And so you can see that Cognitive Services picked out that it's English language, that the key phrases are entire trip, Seattle, and Space Needle, and gave it a really low sentiment score, as it should have, because it's kind of dark and negative. But Seattle's not dark or negative. So pretty cool with that. Here's Google's version of picking out entities. Here, this is the abstract from my talk. I just took it and plugged it into their tester app. And you can see all the bits and pieces it pulls out. These, if you're wondering what you would do with this, these entities can serve as the first level of understanding for the context of a text. Here's Google's sentiment analysis tester app. Again, it took my abstract, it broke it up into sentences, and it gave each sentence a sentiment score. Luckily, my abstract for this talk was pretty positive. So I was glad to see that. Google grammatical parsing. So grammatical parsers, deep grammatical parsers, again, have been around for a number of years in text analysis toolkits. But I think that these cloud versions are trained on a lot more data with a lot more computational power and ultimately very performant inference. These kinds of analyzers typically have been very slow because they are very resource intensive. This gives you a much deeper view into the grammatical structure of the text you're dealing with both a dependency parse and a part of speech parse. And again, this is a jumping off point of once you have this, you can now write rules or build other machine learning programs that ultimately understand the text much deeper. IBM's tone analyzer. I thought this was super slick. So Watson offers this tone analyzer where you not only get a sentiment score, but you get a vector of various, emotions. So it can tell you if a piece of text has anger, disgust, fear, joy, sadness, confidence, tentative, sad, frustrated, satisfied, excited, polite, impolite, and sympathetic. And so for every piece of text you give it, you get a vector with probabilities on all of those keys. So super interesting here. You can see with this one over here, sorry to hear that, both polite and sympathetic. And so this kind of top-level analysis, once you start digging into text analysis, can be super helpful for building your application. So how do these competing offerings compare? It's hard not to notice that many of the big guys and the little guys are offering competing offerings that are very similar. So one obvious question is, well, which one should I choose for my application? Does it make sense to ever use multiple versions of these? Would I ever use Amazon's face detector along with Google's face detector, for example? And so to answer these questions, we built a very simple empirical comparison tool to look at model performances side by side. And so here we're comparing OCR implementations. And it's a pretty simple UI. On the left is a variety of input sources to choose from and experiment with. In this case, this is a handwritten note by Mario Benedetti. And you can use the left and right arrow buttons to look at different input sources that we've pre-chosen. And then you can see the following boxes of Google, IBM, and Microsoft and how well they did. Suffices to say Google nailed this one. Here's another one. This obviously Hayden Ashbury in San Francisco. Again, Google did really well on this. IBM did okay. Microsoft not so much. But as you start to look at these, you start to think, okay, Google seems to be the best at this OCR or text recognition process. One more here, this movie poster from Jaws. There's text in a variety of different fonts and a variety of different sizes and places in the image. Again, Google does really well here. Although, as you'll see coming up, don't worry, some of the other guys do well in other categories. Content moderation. So I would have loved to have shown you a lot more output on this because it's pretty interesting, but I think I'd probably get arrested for showing you some of the images that have the more interesting output. This is Miley Cyrus performing live, I believe. But again, you can see, the different vendors providing similar but a little bit different output on the likelihood that this is an image that's safe for work or is offensive or non-offensive. Here's a place where you might start, if the economics were amenable, you might start combining these all into either a single score, or you could even feed these into your own classifier to decide if this piece of content does need to be moderated for your application. Here's sentiment analysis comparisons. You probably can't see this as well. I apologize. It's a lot of JSON output. But there's a lot of variance between what people output, what different vendors output. I talked about IBM and their emotions detector, and Google. Microsoft here just gives a single score on sentiment. Amazon has a little bit more detail. Speech to text. So, I mentioned earlier this is a long-standing problem, and how deep learning and recurrent neural networks have made a big dent in the problem, although you might not know it from this. Here, nobody gets this exactly right, although IBM came close. And then one more. On this one, Google probably wins by a hair, but they're all, roughly similar. And then, of course, language translation. Again, super hard problem that's been worked on for a long time. Lots of advances recently. If you look closely here, I apologize if you can't see that text very well. We can see that Google and Microsoft do pretty well here. The others less so. And then finally, my favorite, faces. They're all pretty good here, although we see some false negatives, but no false positives. So again, different vendors have a different amount of features that they offer. Amazon's recognition with a K, definitely the deepest there, but Microsoft too offers a number of different metadata about their faces. Again, this is a place where if you could afford to, because most of this stuff is pretty cheap, you might combine all these into a single classifier. Just another one here. You can sort of see who gets who has false negatives basically. I don't think I've ever seen too many false positives. Okay, so case studies. So we build a lot of prototypes at Madrona Venture Labs, Ejiro and I, and we use a lot of these services to basically, do proof of concepts and bootstrap. And so, we've used sentiment analysis for a number of projects, and the emotional analysis I was talking about in various text machine learning problems we work on. With home decor design, we have used a lot of pre-trained models for building a furniture image similarity engine. It would have been way, way more work had we not been able to leverage a pre-trained model. Text recognition and OCR, totally awesome that this is pretty much a solved problem now, particularly with Google. So we're able to start thinking about, well, what if we had an application where a user used a mobile device to take a picture of a bill they received in the mail, or an explanation of benefits they received from a health provider, and know that we'll get a robust representation of that data digitally. And then we've used some speech-to-text functionality here for some meeting analysis ideas we've worked on. So challenge with PTMs, I'm not going to go too much into it because some of the last speakers talked about some of the challenges around these, but it's hard to interpret some of these deep neural network models, and that matters more for some applications versus others. One of the things that really kind of stuck out to me is I'm willing to pay for your service, Mr. Google or Amazon or Microsoft, but how accurate is it? Why can't you report on basic like n-fold cross-validation accuracy to me? Can we come up with standard data sets to run through all the different vendors to see how they actually compare analytically and not just empirically? Of course, cultural bias was talked about in some of the previous talks. Very big issue that we have to deal with as a society. You know, with face detection, it's probably, and I think I've seen some articles around this, various face detectors are not very good at non-white faces. That's obviously a big problem and one that has to be dealt with. Then we can skip the adversarial examples. So really quick, I didn't get to this. I didn't get a chance to get to this, but these pre-trained models can be customized easily, especially convolutional neural networks. And they can be customized with really small amounts of training data. And so you're starting to see cloud offerings from Google and Microsoft providing a service around this, although it sort of can be easy to do this with a really large model on your laptop. But this opens up all kinds of new possibilities. Suddenly, if I want a custom model, I don't need to train up my own one from scratch with millions of examples and billions of features and floating point operations. I can just take an existing model from someone and really kind of subclass it for those that are familiar with object-oriented programming with a very small number of training examples, which is usually, getting enough training data is usually the bane of existence of a typical data scientist. And so then just go to the second to last slide and we can be done. One more. So conclusions. Data scientists fear not. Manual machine learning model building is not going away. But I hope that this trend with pre-trained models is going to empower a lot of people that ordinarily wouldn't be empowered. So what's the depth of product use cases that PTMs can support and satisfy? I think it remains to be seen. And as devs catch on, will there be a demand for more specific granular models? What other types of common machine learning problems can be generalized and benefit from customizable base models, e.g. churn? We all know, I think, many of us know that predictive analytics grew up around churn problems, and every subscription company and its brother has a data science department working on churn. Why are we all solving the same problem over and over again? Can we have a base model that can be customized by people that figures out churn? How can we overcome the challenges with PTMs? As I mentioned, lots of big challenges there with regard to explainability and cultural bias and so forth. But most of all, I want to leave you with all you guys to experiment with making your app smarter. Try out some of these PTMs. And that's it.